Welcome back, Algebra 2 students. Today we're going to be talking about section 13.3, which is evaluating trigonometric functions of any angle. So let's start off by getting a title on our paper. Okay, so when we evaluate trig functions for any angle, we're going to be either given a point or a coordinate on a circle, on the arc of a circle, or we're going to be given an angle theta in degrees or radians, in which case we will assume that that angle will be positioned in standard position on the unit circle, which has a radius 1, otherwise the radius will be specified. So we've talked about SOHCAHTOA previously. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So think about now, I know we have this angle theta in standard position, but think about now this angle here, okay? So the opposite side is going to be our y value. And the adjacent side is going to be our x value, and then of course the hypotenuse is going to be the radius of our circle. Okay, so the sine of an angle theta is defined as, we know it by, so opposite over hypotenuse, the sine would be defined as y over r, or the vertical distance over the radius of the circle. Now we have what we call the cosecant function. We will abbreviate that as CSC, and that is the reciprocal of the sine function, so r over y. Okay? The cosine of an angle theta, we know the cosine as the adjacent over the hypotenuse. So the adjacent is going to be x, and the hypotenuse is the radius. Okay? Now we have what's called the secant function, and we're going to abbreviate that as SEC, and that is going to be, again, the reciprocal of cosine. So flip the fraction and you're going to have r over x. And then the tangent of an angle theta we know as the opposite over the adjacent. So the opposite would be y, our vertical distance, and the adjacent would be x, our horizontal distance. And we have what's called the cotangent function, and we're going to abbreviate that as COT. And the cotangent is the reciprocal, of course, of tangent. So x over y instead of y over x. Okay? So let's do a couple examples here. Let's say we're given a point on a circle, and this point is located on the terminal side of this angle theta, and the coordinate is -4, 3. So that puts us into quadrant 2, and we want to evaluate the 6 trigonometric functions for this angle theta. Okay, so what we're going to do here is we're going to draw the right triangle here. And we know that the y value is -4. And, oops, sorry, that's actually the x value. I'm labeling it as the y value. Let's change that. So the x value is -4. That's the bottom horizontal distance. The y value is +3. Okay? So what we need to know for our 6 trigonometric functions is we need x, y, and r, which is the radius of the circle. So we're going to do some quick math here, and we're going to solve for the radius of this circle. So let's see. We're going to use the Pythagorean theorem. So a squared plus b squared equals c squared, or we can use the formula for a circle, which is x squared plus y squared equals r squared. So x squared plus y squared equals r squared, and we have a -4 squared plus 3 squared is equal to r squared. So 16 plus 9 equals r squared, and then we have 25, okay? So that means that r then is 5. And we aren't going to use two different values like plus or minus 5. We're always going to assume that the radius is positive. Okay, so our radius is 5 units. So we're going to evaluate our 6 trigonometric functions. So then the cosine, actually let's start with sine. The sine of an angle theta is the y value over the radius. Okay, so that's going to be 3 over 5. Okay, now I'm going to go right into its reciprocal function, cosecant. So that's r over y. So then I flip my fraction 5/3. That's the cosecant of angle theta. The cosine of angle theta is going to be x over r. So negative 4 over 5. And then its reciprocal function, which is secant of theta, is going to be r over x, which is negative 5/4. And then tangent is going to be y over x, which is going to be 3 over negative 4, or negative 3/4. And then last, cotangent of theta is going to be the reciprocal. So x over y, we would have a negative 4/3. Okay? Let's try another one here. We are going to evaluate the 6 trigonometric functions for angle theta. Theta is located in quadrant 4, and the point on the terminal side of that angle theta, which is intersecting this circle, the arc of this circle, is 3, negative 3. So what we're going to do is, like we did last time, we're going to draw a triangle. Okay, we know that the x value, the horizontal distance, is positive 3. We know the y value, the vertical distance, is negative 3. That's from the coordinate, the xy coordinate. And we need to solve for the radius. So we're going to use that equation of a circle, or you could also just use the Pythagorean theorem. It's the same thing. So x squared plus y squared equals r squared. So then 3 squared plus a negative 3 squared is equal to r squared. So that gives us 9 plus 9 is r squared. So that is 9 times 2. Isn't that the same thing? 9 times 2. So what I'm anticipating here is that we're going to have to rationalize this number. So then I take the square root, and I get the square root of 9 times 2, which equals 3 root 2. Okay? So you want everything in simplest radical form. So my radius is 3 root 2. Okay? So once I have all 3 sides of my triangle, x, y, and r, then we can evaluate our 6 trigonometric functions. So the sine of angle theta is going to be our y value over our radius, which is going to be, let's see here, a negative 3 divided by 3 root 2. And now that's going to simplify. Here we can cancel these 3's out, and we're going to have negative 1 over root 2, but we have a radical in the denominator. So we want to multiply the top and bottom by root 2 over 2, and that's going to give us a negative root 2 over positive 2. Okay? Now the cosecant of angle theta is going to be r over y. So that's going to be 3 root 2 over a negative 3, and these 3's are going to cancel out, so that's going to give us negative root 2. Negative root 2. The cosine of angle theta, x over r, and that's going to give us 3 over 3 root 2. Okay, So that's really similar to the sine, except for we don't have the negative sign. We did negative 3 over 3 root 2 for the sine, but cosine is positive 3 over 3 root 2. So that's going to simplified be root 2 over 2. The reciprocal of cosine is secant, and that's going to be r over x. Okay, so that's going to be 3 root 2 over 3, and that's going to give us just positive root 2. And the tangent function is going to be y over x, which is going to be a negative 3 over 3, which is negative 1. And the cotangent of angle theta is x over y, the reciprocal function, and we're going to get the same thing as tangent, negative 1. Okay? So I want you to practice here. You're going to give this one a try. Angle theta is located in quadrant 3. Its terminal side is going to intersect this circle, which has the coordinates negative 5, negative 12. So go ahead and evaluate all 6 trigonometric functions. Pause the video. When you're done, you're ready to check your answer, resume playing, and we'll go over your work. Okay, so you should have drawn a triangle in there and used the equation for a circle or the Pythagorean theorem to solve for the radius, which ends up being 13. So you have a right triangle whose legs are negative 5 for the horizontal distance and negative 12 for the vertical distance, and then 13, positive 13, because the radius is always going to be positive for the hypotenuse. So what we're going to do here is we're going to do sine, which is y over r. So that ends up being a negative 12 over 13. Cosecant is the reciprocal, r over y. So that's going to give us a negative 13 over 12. Cosine is x over r. So that's going to give us a negative 5 over 13. Secant, reciprocal. So we just flip it, we get negative 13 over 5. Tangent is y over x, so we have a negative 12 divided by a negative 5 gives us positive 12 fifths. And then flip that, and you get cotangent, which is 5 over 12. Okay? So I know we talked a little bit about reference angles in our last couple of videos, but we're really going to define what a reference angle is right now. So a reference angle is a super useful angle. We've already been using them. You just probably haven't known it. But it's a super useful angle that helps us really define that triangle that we're solving. And it's going to always be an acute angle, so that's an angle less than 90 degrees, and it's going to be formed by the terminal side of angle theta and the x-axis. That's super duper important. It's going to be formed by the terminal side of angle theta and the x-axis only. Okay, and it's always going to be a positive angle as well. So let's practice finding a couple of reference angles here. So what I'm going to do is I'm going to graph the angle negative 150 degrees in standard position. So that is going to put me, I'm going in the clockwise direction, in quadrant 3. Okay, so there's negative 150. All right. Now, the definition of a reference angle said the terminal side, okay? So the terminal side is this side, terminal, and the x-axis, okay? So this would be our x-axis. So then we are looking for this angle here. How many degrees would that angle be? Well, let's see. How many more degrees is it going to take us to get up to that x-axis if we're at negative 150? Well, 180 minus 150 gives us 30 degrees. So that angle is 30 degrees, and that's going to be our reference angle. sometimes they say like, they'll use like a different notation like theta prime, and that's it, you know, not super necessary. I mean, you can do it if you want to, but that's just to distinguish between the two angles. Okay, so let's try number 2 here. We have our angle theta in radians. So we have 2 pi over 3. Okay, so we want to plot this angle in standard position. Now remember that pi over 3 radians is 60 degrees. Pi over 3 radians equals 60 degrees. We have 2 pi over 3. That means 2 times 60 is 120 degrees. So that's going to put us in quadrant number 2. Okay? So here's my angle theta. Theta equals pi, or it's 2 pi over 3 radians. Okay? And I want, okay, that's my terminal side in quadrant 2. I want the angle that is formed by the terminal side in the x-axis. So that is my reference angle right there. And that reference angle is always positive. And when we're given the angle in radians, we're going to express the problem if we're finding the reference angle in radians. So let's see, how many times does 3, how many times does 60 go into 180? Because I want to figure out, how much farther do I have to go to get to that x-axis I'm looking for? So we know that 60 goes into 180 a total of 3 times, right? And we learned from the unit circle that 180 degrees is the same thing as pi radians, okay? So you can think about it like we have 2/3, but I want to get to 1, so how many more thirds do I need to go? I need to go 1 more third to get to 1. So the reference angle is going to be pi over 3. So 1 pi over 3 plus 2 pi over 3 gives me 3 pi over 3, which is 180 degrees. It's pi, radians. It's the same thing. Okay? Alright, so I want you to try a couple problems. What you're going to do is you are going to sketch each angle and then find its reference angle. And I want you to go ahead and pause the video and try these 2 problems, and then when you're done you can hit play and we'll go over your problems. Okay, so for the angle negative 260, we're going to graph that in standard position. Okay, so then I want to go to the x-axis. Okay, my reference angle is remember, it's an acute angle. It's less than 90. So I want to be going counterclockwise here, not clockwise, otherwise that would be an angle that's greater than 90. Okay, so I have to figure out what is the difference between 260 and 180. That gives me 80 degrees. So that's my reference angle. And then 11 pi over 6, that puts me in quadrant 4 in standard position. Okay, so how many more radians do I need to travel to get up to that x-axis? So think about it like, okay, what is the difference between this angle and 360? Or in other words, 2 pi is the same thing as 360 degrees. That's the same thing. So I'm taking the difference between 360 and my angle in radians, of course. So 2 pi is the same thing as 12 pi over 6 minus 11 pi over 6 gives me 1 pi over 6. So that is my reference angle. Okay. Remember, reference angles always have to be acute, so between 0 and 90, and then they have to be positive. Okay? All right, so we are going to now talk about evaluating trig functions for any angle. Okay, so you're going to want to recall your unit circle. It's going to be really helpful for this lesson. So if I want to find the sine of negative 210 degrees, the first thing I want to do is plot this angle in standard position. Okay, so negative 210 is going to put me 30 degrees above the x-axis in quadrant 2. Okay, because 180 and 30 make 210. So I'm going in the clockwise direction. So now, since I know that my reference angle is 30 degrees, okay, that's my reference angle right there. I know that that's 30 degrees. Then I know, then from my unit circle, that the horizontal distance, or the x value, of this 30, 60, 90 triangle is going to be negative root 3 over 2. Let me redefine that negative sign because it got kind of connected there. Negative root 3 over 2, and then the y value is going to be 1/2. And then, of course, my radius is 1. Okay? So what we're doing is we're solving this triangle here, given that we know angle, we're assuming now our reference angle is like this 30-degree angle now, okay? And we're going to find the sine. So the sine is the same thing as the ratio of the y value, or our vertical distance, over our radius of our circle, or the hypotenuse there. So we are going to have 1/2 divided by 1, which is going to simplify to 1/2. Okay? Let's try the cotangent of 5 pi over 3. So what we're going to do here is we are going to draw the angle in standard position. So I'm going to draw my angle. Let's see, 5 pi over 3. I know that pi over 3 equals 60 degrees. So 5 times 60 is going to be 300. Okay, so that puts us into quadrant 4. Puts us into quadrant 4 here. Okay, so let's see here. So we went 5 pi over 3 radians in the counterclockwise direction. That puts my reference angle at, let's see, how many more degrees would it take us to get to 1 full rotation? Well, that would have to be pi over 3, because 5 pi over 3 plus 1 pi over 3 gives us 6 pi over 3, which is 2 pi, and that's the same thing as 360 degrees. So what we're doing here is we're looking at this triangle now, where we know that this angle is 60 degrees, and we know now from the unit circle that the 30, 60, 90 triangle, if the radius of the unit circle is 1, then the x value here is 1/2, and the y value is negative root 3 over 2. Okay? So then cotangent of an angle theta is x over y. So we want to do x, 1/2, divided by y, negative root 3 over 2. Okay? We want to flip and multiply there. Actually, let me rewrite this because I'm kind of running out of room here. Okay, so we had x, which was 1/2, divided by y, which is negative root 3 over 2. We want to flip and multiply. Okay, so negative 2 over root 3. And that's going to give us negative 1 over root 3. And we need to get rid of our radical in the denominator. So we need to multiply the top and bottom by root 3 over 3, and that's going to give us a final answer of negative root 3 over positive 3. Okay, so that's our final answer there. That's the cotangent of 5 pi over 3. Okay, let's try a couple more, and then I'm going to have you try one. Let's try looking at the cosecant of negative pi. Okay, now all these, I'm just referencing my unit circle. I have it memorized in my head. I suggested in the last video that you get it memorized because it really makes it helpful and efficient when you're solving these problems. Okay, so for the cosecant of negative pi, I'm going to graph that in standard position. Now, pi is 180 degrees in radians, so negative pi would just be going clockwise, and that's going to put our terminal side here on the x-axis. Okay, so we know that the unit circle at negative pi there is going to have a coordinate of negative 1, 0. Okay, that's our x value and our y value. All right, and then so that would be the radius of the circle there. So your cosecant is the reciprocal function of sine, right? So it's r over y, all right? So what is the radius of the unit circle? It is positive 1, all right? What's our y value at negative pi? It is 0. So 1 divided by 0, we have 0 under, this must be undefined. So undefined, we cannot divide by 0. And you can also write that as the symbol, we've talked about it before, for undefined. It's a 0 with a big slash through it. You just want to make sure your slash goes beyond that circle so it doesn't get confused with other math symbols. Okay, so let's try one more of these. Let's do the secant of pi over 4. So pi over 4, recall, is 45 degrees. It's the same thing as 45 degrees. So in standard position here, we are at 45 degrees in quadrant 1, or pi over 4. Okay? So my radius, of course, is 1, and then we learned from the last video on the unit circle that the x value is root 2 over 2 and the y value is root 2 over 2. Okay, so if I want secant, secant is the reciprocal function of cosine. Okay, so secant of an angle theta is going to be equal to r over x. And the radius is 1, and the x value is root 2 over 2. Okay, so on this one, we need to simplify. We're going to flip and multiply, and then we're going to work on getting our radical out of the denominator. So we're going to multiply by root 2 over root 2. Root 2 over root 2, and that is going to give us a final answer. Well, no, it's going to give us 2 root 2 over 2, but then we can cancel these 2's out. So final answer, root 2. Okay? All right, so I want you to try a couple of these. Remember, you're really just referencing your unit circle here. So you're going to find the exact value of each of these 4 trig functions. I want you to go ahead and pause the video, try the problems. When you have an answer and you're ready to go over it, you can resume playing. Okay, so let's look at number 1 here. We're looking at the sine of pi over 3. So I graphed it in standard position, and we have a reference angle of 60 degrees. Okay, pi over 3 is the same thing as 60 degrees. So we have our 30, 60, 90 triangle here. Our x value is a half, our y value is root 3 over 2, and our radius is 1. So sine is y over r. So the y value, root 3 over 2, divided by our radius 1, and we get root 3 over 2. Now for number 2, we're looking at the cotangent of 225 degrees. So I graph that angle in standard position. It puts me in quadrant 3 with a reference angle of 45 degrees. So I know at 45 degrees, that's a isosceles triangle, two of the same sides. So my x and y value are both negative root 2 over 2. And of course the radius is 1. But for cotangent, we just need x and y. So it's actually x divided by y, since those are the same number. When you divide them, you get positive 1. For number 3, the secant of negative 330 degrees, we're going clockwise. It puts us in quadrant 1 with a triangle with a reference angle of 30 degrees. Okay, so the x value is root 3 over 2. The y value, the vertical distance, is 1/2, and the radius is 1. So if secant is r over x, then we will have the ratio 1 over root 3 over 2. We're going to flip and multiply. So 1 times 1, 1 divided by 1 times 2 divided by root 3. And then we have a radical in the denominator, so we need to keep simplifying and multiply by root 3 over 3. So final answer, 2 root 3 over 3. And then lastly here, the tangent of 3 pi over 2, that's the same thing as negative 270 degrees. Okay, remember that pi over 2 is the same thing as 90. So if I have 3 90-degree angles, that's going to put me at 270. So since it's negative 3 pi over 2, that puts us at the positive y-axis, and the point on the unit circle there is going to be 0, 1. So since tangent is y over x, then we want to do 1 divided by 0. The x, or the y value divided by the x value, and again we have 0 under, which is undefined. So we can't divide by 0, it's undefined. Okay? So it's going to be really, really helpful for you to get your unit circle memorized before you attempt these problems for section 13.3. And also be sure that you are practicing these problems without the use of a calculator. You really need to get your unit circle memorized, okay? Thanks for watching the video today. I hope you have a lovely day, and we'll see you for the next video, 13.4.